Okay, we're covering section 3.4 today. So today we're also going to be solving quadratic equations, just like we were in 3.3, but we're not going to use factoring today. We're going to use square roots to solve quadratic equations. So we're just going to start with some simple equations. We're going to skip this getting started, and we're going to go to the construct your understanding here. And we're going to do a couple of these questions. Okay, so let's say we have a quadratic equation. This is an example of a very simple quadratic equation because I've got an x squared there. To solve something like this, we have to think about what the opposite of squaring x is. So the opposite of squaring x is to take the square root. The square root and square are opposites of each other. And if I do that to both sides, I'll keep the equation balanced. So that ends up canceling the x squared, and I'll have x equals 4. Now, we have to be very careful with this, though, because there's actually another solution. Remember how in the previous lesson, there was always two answers. When you square a negative number, it also gives a positive solution. So if I could also have x equals -4, because -4 squared would also give 16. So when you take the square root of both sides, we have to remember to include both the positive and the negative answer. So this is how we write it. We do plus or minus the square root of 16. So that would include both the +4 and the -4. Let me show you what I mean one more time. Let's say we had this question here. X squared minus +5 equals 14. So for this one, first we would isolate the x squared. So we would subtract 5 from both sides. And we would have x squared equals 9. Now I want to get rid of the square, so the opposite of squaring something is square rooting, but I have to remember to include both the positive answer and the negative answer. So I'll do plus or minus square root of 9. So I'll have x equals plus or minus 3. So another way to write that in a longer form is x equals 3 or x equals -3. Both of these mean the same thing. The little plus or minus symbol, you write the plus and the minus right underneath. It means +3 or -3. Okay, so that's going to be kind of the key idea today. We're going to be always using a square root to solve. So on one hand side of the equal sign, we're going to have something that's squared, and on the other side, we're going to be squaring that number, or square rooting that number. Okay, so let's go down to some examples here. We will do this one first. We'll do A. So we'll have 3x squared minus 7 equals 8. So we want to always isolate the squared term on one side today. On one side, I can't spell. On one side. So we are going to add 7 to both sides. So we'll have 3x squared equals 15. And then we'll divide by 3. Remember, you're always wanting to do opposite operations. So because we're multiplying by 3 there, we would divide by 3. And now it's time to take our square root. And remember, we have to have the positive and negative answer. So we're going to have the square root on this side and square root on this side with the positive and negative answer. So we'll have x equals positive and negative square root of 5. So it could be positive square root 5 or negative square root 5. And that's my final solution. We can verify that this is true. Let's take the original equation, 3x squared minus 7 equals 8, and plug in, let's just do the positive square root 5. If it's negative root 5, it's going to be the same because when you square it, it becomes positive anyways. So this would just simply be 3 times 5. And this would be 15 minus 7 equals 8. Yeah, 15 minus 7 is 8. So this works out. So a lot of our answers today are actually going to have square roots in them. If it's not a perfect square and you can't take the square root of it, you shouldn't write it as a decimal. You should just leave your answer as a radical. Okay, let's do B. It looks a little bit different. B says x plus 3 squared equals 20. So what we said was isolate the squared term on one side. We actually have that already. We have the something being squared on the left-hand side, and we have 20 on the right-hand side. So we can go ahead and take the square root of both sides right away here. So once your squared term is isolated, then you're going to take the square root. And we want to do the plus or minus. Okay, so here we would have x plus 3, because the square and the square root cancel out, and we have equals plus or minus square root of 20. And then we would simply just subtract 3 from both sides. Now, the square root of 20 cannot be evaluated, so we're going to leave it as a radical. So your final answer is going to look a little bit funny. It's going to look like this. -3 plus or minus square root of 20. You can give an approximate decimal answer if you plug that in your calculator, but we don't need to. We're going to leave it as an exact number here because it's irrational. You could write your answer like this: x equals -3 plus root 20, and then x equals -3 minus root 20. It just takes longer to write out, so I just recommend using the plus or minus symbol. Okay, so that's if you already have a squared term. Now, what if you don't have something that's being squared? So let's go and look at, there's a little explanation that I actually want to go through with you on this side here. So we're going to kind of start halfway down the page here at this. So let's say we're trying to solve this. Now, here we don't have something that is being squared necessarily. We have like an x squared and a 6x. So what we want to do is actually turn this into a perfect square trinomial that we can factor and then use a square root. So what they do here, let's just go through this. So we have x squared plus 6x equals 16. Now, we'll work on how to get this 9, but what we're going to do is add 9 to both sides. And what this does is it turns it into a perfect square trinomial. In math, whenever you add the same thing to both sides of an equal sign, it keeps the equation balanced. So we're allowed to add something to both sides of the equation. It's still going to be the same equation. So notice here, once it's a perfect square trinomial, we can factor it. Two things that multiply to 9 and add to 6 are 3 and 3. So it would factor to x plus 3 times x plus 3, or x plus 3 squared. And then we would take the square root of both sides and have the plus or minus. And so we'd be simply left with x plus 3 is plus or minus the square root of 25, and then we can solve from there. The key to know is this is called completing the square. When we complete the square, there's a little formula that you can use, and it's written right here. The number that is added to each side is the square of 1/2 of the coefficient of x. So it's the square of this, in this case, the middle coefficient is 6. So we would take 1/2 of 6 and square it. So we're going to practice that a few times. It can get a little bit, you do need a little bit of practice to get used to it. So it's called completing the square, shown down there. Okay, so let's practice that a few times in the next example. So it says, check your understanding, solve this by completing the square. Okay, so first thing that you're going to do is, it's the same few steps every time, so you can kind of get used to it. Move constant to right, I'll just use the right-hand side. So we'll have x squared plus 4x equals 3. So we're going to add 3 to both sides. Okay, now we're going to complete the square. Complete the square. Add, so the little formula is you take this number here that's in front of the x, you divide it by 2, and you square it. So 4 divided by 2, and then we square it. So 4 divided by 2 is 2, and then 2 squared is 4. So we're going to add 4 to both sides. Okay, so we'll have x squared plus 4x plus 4 equals 3 plus 4. When you use that little formula, what it does is it creates a polynomial on the left-hand side that can be factored into a perfect square, and then we can use the square root. So if we think of two numbers that multiply to 4 and add to 4, that would be 2 and 2. So this would factor into x plus 2 times x plus 2. And then on the right-hand side, we'll have 7 here. 3 plus 4 is 7. Okay, now we're ready to solve it. We have a squared term on the left side, and we have a number on the right side. So we can take the square root and plus or minus square root. And square root cancels the square, so we'll have x plus 2 equals plus or minus square root 7. And then we just simply isolate x. So we subtract 2 from both sides. Negative 2 plus or minus square root 7. Now, you might be thinking, that seems a little bit hard. Why wouldn't I just solve by factoring here? So actually, if you tried to solve this by factoring, you would notice that you actually can't factor this question. So if you tried to think of two numbers that multiply to negative 3 and add to positive 4, you can't think of the numbers. This equation is impossible to factor. So one advantage of the completing the square method is that it always works, even if the quadratic equation cannot be factored. And sometimes your answers are going to have square roots in them. And if they do, you just leave those like they are. Okay. Let's try one more. This time we're going to have a little bit more of a complicated situation. So I'm going to do A, and then you guys can try B on your own if you like here. What happens if the coefficient in front of the x squared term is not equal to 1? If it's not equal to 1, then our little formula for completing the square is not going to work. So what we have to do at the very start is multiply by something that gets rid of that and changes that coefficient in front to be 1. Both sides by 2. So in this case, I'm going to multiply by 2 because that's going to multiply with the 1/2 and create 1 as my leading coefficient. And then I'm not going to have to worry about those fractions anymore. When you multiply equations, you have to multiply every single term or else it makes it unbalanced. So the first term will be x squared. The second term will be 6x. 2 times 9 over 2 is just 9. And then 0 times 2 is 0. Okay, great. Now we're ready to move the constant term over and solve this like normal. So we're going to move the 9 to the other side. We'll have x squared plus 6x equals 9. And now I'm going to complete the square. Add, so remember we take this middle number, so in this case 6, we're going to divide it by 2 and square it. And that's what we're going to add to both sides. So 6 divided by 2 is 3. And squaring 3 is 9. So I'm going to add 9 to both sides. And if I add it to the left side, I got to add it to the right side. Okay, and let's factor now. So this will factor to x plus 3 times x plus 3. If you use this little formula, then you'll always get a perfect square when you factor. And then we take the square root, we don't forget about the plus or minus. Okay, then we'll have x plus 3 equals plus or minus square root of 18. And then we simply subtract 3 from both sides to isolate the x. So here are our two solutions, negative 3 plus square root of 18 and negative 3 minus square root of 18. Okay, and we could see those are the answers there. Okay, so let's just quickly go over one more time. When you have a coefficient that's not equal to 1 as your leading coefficient, you want to multiply both sides of the equation by something that's going to make it 1. So in this case, that would be 2. In the next example, you would want to multiply both sides by negative 1 over 5, because that will cancel with the negative 5 and make that leading coefficient 1. So whatever is going to multiply and make it 1, that's what you want to multiply by. You move your constant to the other side, add your perfect square number, and then square root both sides. Okay, let's go to the final example here. We're going to do a word problem today together. A lot of word problems in this section are going to involve people throwing things into the air, because when you throw things into the air, the natural sort of formula that comes out is a quadratic equation for the height of that object. So in this case, we're throwing a stone up into the air. We're standing on a cliff, and the cliff is 55 meters high. We throw a stone up in the air, and then it lands in some water. And so here's a little formula that models this scenario that's happening. And it says, when will the stone hit the water? So in our little formula, h is the height and t is the time. So the question that they're asking is, when will the stone hit the water? When you hit the water, the height of the stone will be 0. So in our equation, we're going to replace the h with 0, and I'm going to solve for the time, or the t value, using my completing the squares. Okay, so I'm going to use that same equation, except I'm going to have 0 equals 55 plus 30t. You might have a different scenario where you're asked to find a different height, and in that case, you wouldn't use 0 on the left-hand side there. You use whatever height you're asked for. Okay, and now I'm going to rearrange this and write this in the other order that I'm more used to, where where this number comes first. Okay, and then we want to multiply by something to make that leading coefficient equal to 1. So in this case, I'm going to multiply everything by -1/5. -1/5, just because that will create a leading coefficient of 1. So 0 times -1/5 is 0. That'll be 1t squared, and then I'll have -6t, and I'll have -11. Now we move the constant to the other side. So we'll have, and I'm used to writing it the other way, so I'll write it like this, equals 11 plus 11 plus 11. Okay, and now we add, complete the square. Remember, you take this middle number, so in this case, -6, you divide it by 2, so that would be -3, and you square it, so it would be 9. So we're going to add 9 to both sides. Oops, the wrong color here. So that's t squared minus 6t plus 9 equals 11 plus 9. Then I'm going to factor. This would be t minus 3 squared. Two numbers that multiply to +9 and add to -6 would be -3 and -3. And then I'll have 20 here. Square root plus or minus square root. And I'll have t minus 3 equals plus or minus square root of 20. T equals 3 plus or minus square root of 20, because you add 3 to both sides. Now, when this is a word problem, usually the question will ask you to write an approximate decimal answer so that you can put it in the context of the scenario here. So we're going to actually use our calculator here, and it says give the answer to the nearest tenth of a second. So let's plug in both answers. T equals 3 plus root 20 and t equals 3 minus root 20, and see what those are equal to. 3 plus root 20 is about, I'm going to put a little dot because I'm rounding, 7.5 seconds. And 3 minus root 20, I'm just using my calculator, is about, plugging the wrong thing. There we go. Is about -1.5 seconds. Now, obviously, you can't have negative time in this scenario. So this one is going to be the only appropriate solution here. So approximately 7.5 seconds after you throw this stone, it's going to hit the water. And there we go. That's the end of the lesson.